This is video number 2 for checkpoint quiz 11.1. Problem number 2. We want to analyze the displacement of a mass suspended on a spring if the displacement is governed by y equal 15 times the sine of 8 pi t. Okay, in problems of this type, we are looking at harmonic motion. Harmonic motion has one of the following forms. Y is equal to a times the sine of omega t, or y is equal to a times the cosine of omega t. We're looking at harmonic motion with no phase shift and no vertical translation. When you see one of these types of equations, the absolute value of a is going to be the amplitude. That's the maximum spring stretched. Omega is the angular frequency, and the period, which is the time to complete one cycle of motion, is given by t is 2 pi divided by omega. The regular frequency is denoted by the Greek letter nu, which is equal to 1 divided by the period. And this is the number of cycles per unit of time. And the period is the time it takes to complete one cycle. You have a spring suspended, let's say from the ceiling, and the equilibrium position is the place where the mass is at rest. And we're going to say this is y is the 0 position. And typically we denote positive values going upward and negative values of y downward. And so we stretch the spring, it stretches to a maximum displacement, and then it releases and it produces harmonic motion. In the original problem, let's put some units. Y is measured in inches and t is in seconds. We want to compare our particular equation, y is equal to 15 sine of 8 pi t, and compare it with our basic harmonic motion equation. It tells us that the amplitude is going to equal the absolute value of 15. The amplitude is 15 inches. We see from our equation that omega is 8 pi, therefore the period is 2 pi divided by omega, which is 2 pi divided by 8 pi, and when you simplify 2 pi divided by 8 pi, you end up with the period is 1/4, and this is in seconds. So it's going to take 1/4 of a second for the graph to complete one cycle of motion. We can find the regular frequency, nu, is 1 over the period, so our frequency is 4 cycles per second, and the units is hertz. The unit of frequency is measured in hertz. Here's what the graph will look like. Here's our coordinate system, time, and displacement y. The period of 1/4 second tells us that the graph will make one complete cycle in that 1/4 second. So if I have units of time, this is 1/4, then 1/2, 3/4, and 1 second. The graph will make a complete cycle within each of these quarter unit intervals. The graph of the sine function increases from 0 and goes to a maximum and decreases down to that minimum and back to 0 again. We'll see that shape repeated within each of these little quarter second intervals. Amplitude up at 15. Here's the cycle. The graph increases, gets a maximum, back to 0, hits that minimum, and there's one complete cycle in that quarter unit of time. 4 complete cycles in that 1 second. So this will be repeated over and over again.